Greeting everyone, this is Mohammad Alshehri and I'm happy to present to you my project, which is the FIFA World Cup Matches Analyzer that is built on top of an EDFS. So starting with the agenda, in this presentation I will give you an overview about the different components of the project. Then I will speak about the EDFS part. I will follow that by speaking about the FIFA application, which is the core of this project. And throughout the presentation I will present different architecture and design diagrams to help illustrate the details of this project. So starting with the overview, we have the EDFS and we have the FIFA Matches Analyzer application. The EDFS is built as a complete standalone application. It can support any other external application that wants to use this EDFS as its own file system. So it has its own APIs that are exposed, it has its own command line, and although it is optional for a team of size 1 to have this, I developed the graphical user interface because I found it more appealing and more user-friendly. Then we have the FIFA Matches Analyzer application. This application is designed to perform search and analytics on FIFA historical data. It is fully running on top of the EDFS. It has its own command line, and similar to the EDFS, I developed the graphical user interface for this application as well. So looking at the architecture of the EDFS, we have the EDFS system, which is built using Python. It has its APIs exposed, and all the data for the EDFS are stored on Google Firebase. So as you can see on the left, we have two JSON objects in the real-time database in Google Firebase, which are partitions and structure. So if we look at the right, we can see the structure JSON object. It is simply made of nested JSON objects that represents the hierarchy in the actual EDFS file system. So if we look here, we can start from root, then we can look at FIFA data, which is a folder. Then we can see that there is a file here called internationalmatches.csv, and below each file we will find a list of partitions, and this long number represents the partition ID for that file. As you know, there are different limitations when it comes to storing data as JSON objects. For example, the keys cannot have dot in them, the character dot, and the EDFS overcome these limitations by using placeholders. For example, the dot is replaced by 2 underscores, and once the data is taken back into the EDFS system, it will be fixed and presented properly to the end user. So this is the partitions JSON object. It is simply made of a list of key value pairs, where the key represents the partition ID and the value represents the actual content of that file for this specific partition. As you can see, this is not human readable because when I store the data in Firebase in JSON objects, I encode them using base64 encoding. And the reason I'm doing this is because I want to make sure that all kind of data can be stored. So this way we can make sure we are not limited to text and CSV files and so on, but we can store different types of data, including images and videos and so on. So moving on, we can look at the different APIs for the EDFS. The EDFS support things like creating a directory, listing the contents of a specific path, retrieving or displaying the content of a file, which of course corresponds to all partitions. We can remove a file or folder. We can upload files using either the put or the put CSV commands, which I will talk about. And we have get partition locations if you want to see the list of partitions for a specific file. We have read partition, where you can read the content of a specific file for a specific partition. And we have the isExist if you want to query about whether a file exists in the EDFS or not. So when it comes to the upload, we have put and put CSV. And the main difference between these two commands is the way partitioning is happening. So put can be used for any file, and partitioning is happening based on the size of that file. So the default partitioning is 1 partition per 1 kilobyte. So if you have, for example, a 5 kilobyte file, then uploading that file will correspond to 5 partitions, where each partition will be 1 kilobyte. or you can mandate the number of partitions during the upload itself. Then we have the other command, which is the put CSV, and this is a specialized function. It is meant for CSV files only. The main difference compared to put is the way partitioning is done. Here it's not based on the file size, but it is based on the number of lines. And the default is one partition per 100 line. So for example, if we have a CSV file that has 300 lines, then uploading that file using put CSV will correspond to 3 partitions, where each partition will have 100 lines. And the main reason I have this special function is because it will come handy to upload CSV files and partition them based on lines when it comes to using the map and reduce functions, because this way you can have each mapper linked to a specific partition, and each partition will contain valid number of lines rather than partitioning randomly based on the size of the file. So moving on, we have the EDFS command line user interface. So we can take a quick look at the command line user interface, then we will look at the graphical user interface. So this is the EDFS fully functioning command line user interface. We can go to FIFA data folder, for example. As you can see, we can go back, and this is the actual file actually that is being used by the FIFA application. We can do cat, for example. Let's do cat hello world to display the contents of hello world text. As you can see, this is the content of the file, and I will show you the rest of the commands, which are the upload and making a directory and so on, in the graphical user interface, because it's more user friendly and to save time as well. So moving on to the graphical user interface, let's do a live demo actually. Let's open the EDFS. So as you can see, this is the EDFS graphical user interface. It is built using C#, and I will talk about the design and the architecture in the next few slides. So as you can see, it's very similar, and it's designed to standard file explorers. You can double click on a folder to navigate there and look at its contents. You can navigate back, you can go into other folders and so on. So let's try creating a new folder, for example. Let's call it project. So once created, we can go into that folder, and let's, for example, try one of the upload functions to illustrate how it works. So this is a file called country list. Let's open that file to take a look at its contents. So as you can see, we just have a simple CSV file which has a list of countries and their capital cities. So let's go back and let's upload that file into the EDFS. So the application gives you optionally the option to mandate the number of partitions, or you can leave it empty for different partitionings. But let's say 6. Let's say we want 6 partitions for this file. So once we click OK, the file gets uploaded into the EDFS. So to show you how we can display files, we can double click on the file. For example, it will show us the file name, it will show us all the partitions for that file, and we can even double click on a specific partition if we want to display the content of that partition specifically. So we have the file country list.csv. This is the partition number, and this is the content for that partition. Additionally, we can say display file content if we want to display the whole content of the file, not only a specific partition. And you can see this is all the content of the country list CSV file. Going back into the main screen, we can, for example, delete this file if we no longer want it. And I guess this concludes the graphical user interface presentation for this EDFS. It's simple but effective and user friendly. So going back into the slides, let's take a look at the architecture of this EDFS and the graphical user interface. In case you were wondering how the C# application was, with its graphical user interface, was communicating with the EDFS system, which is built using Python. So I added a small Python script that I created which does this link. So this application simply takes commands from the C# and executes the APIs on the Python EDFS system. I can even give you a quick look over how this works. So whenever the C# application wants to execute a command, it will write the API command details that it wants to execute to this file, link.txt. Then it will start Python and it will start the link script that I created, which is this one, to give you a quick look. So this is the link application. It will just simply take the API command from the link.txt, and now since we are in Python, we can import the EDFS itself. We can execute all the APIs that we want based on the command that is being requested, write the results back to file, and close. So once we close the file, the C# application will be waiting for the results. It will process the results once available, and it will display and process the results to the user in the graphical user interface. So moving back into the slides, we can move on to the actual FIFA application, which is the main thing in this project. As you can see, we have a graphical user interface to show you here. So let's go to the FIFA application here. Yeah, so this is the FIFA application, and we have two main functionality in this application, which are search and analytics. So let's start by doing search. So the search allows you to simply filter over all the different results that are available in the dataset. So the dataset contains all the FIFA matches in the history of the FIFA World Cup. So you can simply search in this data. So let's say you are interested, for example, in seeing all matches for USA team. You can specify another team if you want to see the matches between these two teams, or you can leave it empty if you want to see all matches for USA. So let's say you want to see USA matches that started from 2010 until, for example, 2018. Then we can do the start searching. We can even specify a minimum score gap if you want to see matches with the score gap of 3 or 4 goals, for example. So if we do the search, then we can see the results. This is quite a long list, a little bit. Anyway, this is how the search function works. And to give you an idea of how this works exactly, let's look at this diagram. As you can see, we have different partitions in the EDFS for the dataset. So what is happening is that a mapper will take care of a partition. So we have n partitions and n mappers, where each mapper will take care of the data in one partition, and then all of the filtered data will go to a reducer, and in this case the reducer will just collect the results and display them to the user. And to show you how this is working in practice, we can look at the FIFA app from the command line user interface. Let's do search, let's do USA team. We don't have to specify any other filtration conditions, just for the sake of illustration. So as you can see, we have one mapper doing the filtration or the search on one partition. Once all data is collected, we can just display them. So this gives you an idea. So let's go back to the FIFA application itself now to look at the other function, which is the analytics, and this is very interesting. I really enjoyed developing this part. So let's look, for example, at Argentina, for example. So the main idea is you need to specify one team that you are interested in looking at the statistics for that team, Argentina. So you have two different ways of looking at it. You can either say Argentina and that's it. You want to look at Argentina's statistics throughout history, or you can specify another team if you want to see how these two teams are competing. Let's keep it to Argentina. Let's add no date range. Let's keep it all history. Let's do perform analytics. So as you can see, the filtration, the analytics, everything is completed, and we can see the statistics for Argentina. So Argentina is winning 58% of the time. That's quite good actually. Losing around 20% and doing a draw around 20% as well. So this is the first part. So if we do the analytics again, let's do the other part, which is looking at how two teams are competing against each other. So for example, let's do Argentina as the first team and let's do Brazil as the second team. I guess these two teams are known to be rivals. So Argentina versus Brazil, we don't have to specify a date range, a specific date range if we want to keep it throughout history. Let's do the analytics. As you can see, Brazil is actually winning 60% of the time, and 12% of the time it is a draw. So this is the analytics part of the application. So coming back to the slides, looking at this second diagram now, which corresponds to the analytics part, it's similar to the search part except for the reducer. So now each mapper will take care of a partition to do the filtration, and once all the filtered results are completed, it will be sent to the reducer, where the reducer will take these data and perform the analytics to determine the win rate, the lose rate, the draw rate, and so on, and present it to the end user in the application graphical user interface. So looking at the architecture as well, as you can see now, we have one more component in this diagram, which is the FIFA matches analyzer application. So the FIFA application connects to the EDFS system through the APIs to read the data and the partitions and so on. It has its own command line user interface. And the end user FIFA application is built on C# as well, and it connects to the FIFA application now through its own APIs as well. And similar to the EDFS system, we have this small Python script to handle this API calls from C# to Python. So by this I conclude my presentation. I hope you enjoyed the slide and wish you all best of luck. Good luck.